So I had a lot of fun playing around with JavaScript and GLSL recently. So earlier this year I decided to enter this JavaScript 1K competition where you had to create a cool effect in less than 1 kilobyte of JavaScript. And this here is actually not that entry. It's because the one for that was really slow. So I did another version in GLSL, which is a lot faster. And it's looked a bit boring, but it'll change once I muck around with it a bit. So basically, the idea of this is to capture the concept of infinity. And I don't know if there's any math geeks in the room or people who really like mathematics, but a while ago I came, if you study mathematics for a while, you come across the concept of different kinds of infinity, where the natural numbers, the counting numbers, are one form of infinity, and then the real numbers, which have fractions, infinite decimal expansions, are also infinite, but they're actually more infinite than the counting numbers. And I found a way to express that visually, I think, because it's usually a really abstract mathematical argument to show. So we've got our love heart here, and we can move it around and zoom in on it, and it's not a bitmap. This is functionally generated in real time. Pretty boring. If I press a key, then now we have tiled that infinitely, so I can move around the field, and it's infinite. Again, pretty boring. But if I go to the next step, what I do is I map that infinite number of parts into a finite space. And it really is an infinite number of parts. So if I zoom in on the corners, you can see they just go on forever. So they're getting quite tightly packed there, but there is an infinite number of parts there, and you can do that. The question there, why stop here, right? So why not tile an infinite number of those? If I zoom in on any of those, that's still infinite. Let's zoom out. Why not map an infinite number of those ones onto that? So now we have infinity within infinity.
And it still loves you.
And it still loves. So, this is real. I can zoom in on any of these ones and start exploring its infinity. And you can actually go on forever with this. So I'll go 2 more steps. And so I can zoom in on one of these, and then zoom in on another one. And down to the infinite number of parts. It gets a bit silly after a while. So that's as far as I'm going to go on that one. Okay. So the other thing I did was I just finished it last night. So I was reading this blog post. This guy came up with this idea. So really the thing I'm going to show you is like the last 1% on the 99% work that he did. But what he did is he came up with this cool idea for something called a factorization diagram. What it does is, well, let's talk about prime numbers. So prime numbers, well, let's talk about numbers that are not prime first. So let's take the number 6. It's 2 times 3. Okay. So the thing that's special about 6 being non-prime is that you can group it. And I think this is not usually how prime numbers are taught, but you can form it into groups. So like 6 can form into 3 groups of 2, or 2 groups of 3. But a prime number like 5, you can't group it in any way. You can't do 2 groups or 3 groups or whatever. It's completely indivisible. That's essentially what multiplication and division are all about. They're about grouping. So this is a number. It's 700. There are 700 dots there. And what it's showing is its prime factorization. So we have like 7 big groups. And within those 7 big groups, we have 5 groups of 2 groups of 2. So if you multiply that all together, it comes up to 700. And every number has a unique prime factorization. So like prime numbers are the multiplicative building blocks of numbers, pretty much. So he, talks about how he programmed this thing. But I guess the interesting thing to look at would be the first 36 numbers, I think it is. So there's 1, there's 2, there's 3, like 2 groups of 2, and then 5 being prime, you sort of just equally space them around a circle. Then you have 6, which is 3 groups of 2. He hasn't chosen to do it the other way around, so it's kind of in reverse order of the primes. So it's 3 groups of 2 rather than 2 groups of 3. Although you do have a choice there, but he's chosen to do that. So if you look through here, visually it's really easy to pick out which ones are the primes. They're all the ones which are like shown as circles. You know, which I just think this is really cool. So that there is 9, which is 3 groups of 3, and so on. And each one of them has a unique shape. So all I did is just go the extra step and create a little animation that just transitions between each of them, each time adding a new ball, and it will just keep going up to 1,000 actually, although I don't have to set it at 1,000, it could be totally arbitrary. So basically it just does that, and it's nice to look at. Okay, that's all. So, anyone else?
Anyone else? Show and tell?
Yeah, right.
Does that go infinite as well, man?
It only goes up to 1,000, but I don't know why I did that. Could be an infinite loop. It'd eventually spill over. There'd be an integer overflow eventually. But at 4 billion, I think. Then again, it's in JavaScript, and all numbers are like floating points in that. So I don't know, actually. Yeah.
Alrighty. No more show and tells? Okay, well, thank you for coming.
Thank you.
I'm Ben, by the way. I organised this in place of Pia. She's in Japan, so I'm taking over. But I expect you'll see Pia again next month. Thanks for coming.
Oh.